Don't know how to enlarge the fonts. Sorry. Okay. So today we'll introduce two libraries for working with different kind of cryptographic hash functions. The first one is you must have an object like M or whatever you want, whatever you like. Hash famous graphical hash algorithms which is used in different cryptocurrencies like Bitcoin. Okay, so by this now we have an object M. M is an object of type SHA-256. Now this object, this method takes an input of type byte and generate its hash value. Okay, so I want hash my name. I want to name. So this B converts the string a byte. Okay, as I said, update takes put which its type string to byte. You should put a B in front of that string. I put my name here. So this command converts my name to a hash value based on SHA-256. But to add another thing, at that string, and I want to recalculate hash value. To do so, I m.update. Now my family, which is an space in front of it. Again, I convert type byte. Maybe you say you would write something like this. Yeah. I want to calculate a string, and later I know that you can simply use a string at the as the param update, something like this. Update means update. Update. The meaning is not important. Update. This method update calculates the hash functions, all the hash functions, takes one input, its value. And now my first input is Wahid, and the second is my family, and updates hash value. And now I want to print the hash value. To do so, I use the print command and value. I convert hash value to hexadecimal by this command, hex digest. So this command prints the hash value as a hex format, and then later on prints again that hash value in the byte format. So if I this simple program, this is the hash value my name and family. In fact, the input was okay. In the second part here, again, this part is as of using 2 times update. I just used 1 update, but I put all the data as 1 parameter. So they takes just 1 parameter. My name, space, family, my family, okay? And the hash value as a hexadecimal format, as a binary format. If I run it, see, the result is the same. Not sure. This program was the same. The input was the same. You think put, you know, Hassan, well, I want to show you how use these library methods, how to calculate hash values. You can put every. So I want to say that you can put all the string you can put in different steps. 1 time, 2 times, 3 times, 4 times, whatever you need. Update in a program, it's okay. First library. You don't have. Can you hear me? I think it says me that everything is okay. So check your problem. Okay, let's go. Again, for calculating the hash values, you can use another cryptography. This one was hashlib. Okay. There is no difference, both the same, but just the way of the representation is different. This is in hexadecimal format. Each hex digit, as you know, is 4 bits, okay? But here is exactly this data, but in the binary format, bit format. So it's byte, it's equivalent in hexadecimal format. Okay, both the same. I want here, I want to show you how to convert hexadecimal. This is a hexadecimal. And by this command, bytes from hexadecimal form byte. Later, we need this. System is okay. Unfortunately, I think, but everything is recording us. You can download the recordings, and I'm sure everything is okay. So, converting a hexadecimal equivalent in format. They said sessions we need these commands. Okay, we will use it more than hashlib is cryptography. For cryptography, you must write a command like this: pip install cryptography, and you should have an internet connection. When you run this command, the in fact tries to download and install, but in my system this library was installed before, so you see something like already satisfied. Okay, so for the first use, at first using this pip install cryptography, you must install this library. This library has different parts. For using especially SHA-256, you should use cryptography hazmat primitives, and hazmat primitives you must import hashes. Okay, just use this command, and now again I define an object with hashes library, hashes, hash, which takes a parameter, and that's the name of the algorithm. In this case, I want to use. So now I have an object. Again, using update command, in this case, both libraries are similar. Using update command, I give my data calculating the family. Here you can use hex digest like this. Is by this command that finalize the digest now is the value. I can simply print the digest, or I can print the digest.hex. Okay, if I run, both are the same. This is format, a byte format, as you can see, exactly the same as before, even though the libraries are different, but terms are the same. Both are 156 So not so. This is $56 because output is 200. As I said, each bit is 4 bits. So 256 divided by 4 will be 60 digit. It's a 64 length strings. 64. Okay. Again, you can convert this hexadecimal. I copy it. I put it here. Can convert hexadecimal format to byte format. See, again, the first and the third output are the same because both are byte form. We will use them in later for calculating some cryptographical, some critical messages for encryption, decryption. Okay. You can use different algorithms, not only SHA-256. You can use SHA-1. SHA-1, the output of the SHA-1 is, I think, 160 bits. 160 bits. Okay. So simply, when you are using cryptography library, or even when you are using hash library, you can change the name of the algorithm. For example, SHA-1. Okay. Simply. Obviously, the output will be changed because the algorithm is changed. Okay. Different SHA or SHA algorithms. SHA-1, you can use SHA-1. Output is 160 bits. Use SHA-200 or SHA-56, which are 224 bits or 256 SHA-8. Or SHA, not only it's a part of the name of the algorithm, but also it's the size of the output in bits. Okay, it is the size in bits. For example, SHA 384 generates hash values which has a length of 384 bits. Okay, so this is, you can put everything you want here. Every data. So this is about cryptographical hash functions. Most of the cryptocurrencies are using this SHA-256. Nobody could broke it till now. It's working. Okay. if you have any question, please let me know. Otherwise, encryption and decryption and RSA algorithm. So till now, we saw MD2 algorithms and their associated libraries and commands in Python. Please note, all are one-way functions. What is one-way function? What is when I say this algorithm a one-way function, what is mean? Yes, you cannot use it by reverse. For example, using the output, for example, using this, you cannot guess the input. So it's one-way function. Using the output, you cannot find, even you can't guess the input. Okay? If you don't have any, let me start the new topic. No question? Okay. Okay, now I want to talk about cryptography. What's my problem? My problem is, let me use the whiteboard. I'm here. Suppose that I'm Bob. Okay. Here is Alice. Now I want to send a message to Alice, but encrypted. Nobody, like Eve, I don't want to know what's my message. Cryptographic hash functions like RSA, like SHA-1, SHA-256 don't work here. Why? For example, Bob cannot use SHA-1 to encrypt his message and sending them to Alice. Can you explain why? Here we need new algorithms. Algorithms like SHA-256 doesn't work here. Who knows? My problem is, please note, my problem is Bob wants to send a message to Alice, and Bob wants Alice to read his message. But Bob wants nobody else, like Eve can read its message. So he wants to encrypt the message and send the encrypted message to Alice. When Alice receives the encrypted message, she must be able to decrypt the message and read the message. Okay, now my question is, why Bob cannot use an algorithm like SHA-256? What's the limitation? What's the problem with SHA-256 for encryption? For using as an encryption? SHA is a cryptographic hash function. It's not an encryption decryption algorithm. Why? What's the problem with SHA that we cannot use it as an encryption algorithm? What's the answer? No. The length is not the reason. Key? No. Yes, exactly. I think Nur Adnan got the point. As I said, hash functions are one-way functions. It means that, okay, Bob can simply hash his messages using SHA-256 and send the hash value to Alice. But how Alice can decode it? I said Bob wants to send the message to Alice, and Alice must be able to read the message. But how? Okay? So those algorithms like MD or SHA are hash functions one way. For encryption and decryption, we use another algorithms. One way. We cannot use them for encryption and decryption. Hash a message and sends the message to Alice, but Alice cannot decode the hash value. As I said, it's a one-way function. It's not possible to find the input from the output. So we need some new algorithms. One of the most famous algorithms is RSA algorithm. RSA is an encryption decryption algorithm. Okay. Another one is elliptical curve. In Bitcoin, elliptical curve encryption decryption algorithm is used. So in the current session and in the next sessions, I will talk about RSA and elliptical curve. One of you asked, what's the use of SHA-256 if it's one way? It's used beside encryption decryption algorithms. For example, for a simple example, everybody must have a everybody must have a public and private, and also everybody must have an address, valid address. All valid addresses must have the same structure. So Cryptocurrencies wallet address is the hash value uh, of the public address. Okay, so later when I start talking about blockchain, I will exactly explain what's the application of cryptographical hash functions, what's the application of encryption decryption algorithms in the blockchain. Okay, just for now let's understand how they work. What are they? Okay, in the first session I talk about public key and private key and symmetric and asymmetric encryption decryptions. Again, suppose Bob wants to send a message to Alice. Okay, and he doesn't want to know, for example, Eve, what's the message. So there are two different approaches. One, which is an old approach, is called symmetric. Symmetric, and the new approaches is asymmetric. Okay, in symmetric approaches, Bob locks the message with a key and Alice unlock that message with the same key. For example, suppose that this is the message, okay, and suppose that key is 2, and Bob uses a very simple encryption algorithms. Bob converts each character to another character which has an ASCII code with the previous 2 characters after H. Okay, 2 characters after E is G, small g, and 2 character after Y again is A. Consider alphabets are circularly, okay? As a circle, consider the alphabets on the environment of a circle. Okay, so receives JGA. Now Alice is using exactly the same key decrypt by using 2 characters before. Bob used 2 characters after, Alice used 2 characters before, finds the message. This is a very, very simple example of a symmetric encryption. In this approach, there is only one kind of key. Both sender and receiver has the same key. This kind of encryption is not so strong. So from at the end of year 79, new algorithms which are asymmetric are used. What's an asymmetric encryption or decryption algorithm? In asymmetric approaches, there are 2 kinds of keys. One is what's called public, and the other is private. Okay. So in asymmetric encryption decryption approaches, we have 2 kinds of keys: public key, private key. So everybody in the network has 2 keys: public key, private key. Private key is private. Everyone knows only his own private key. Consider email. For example, my email address is v.rafe@gmail.com. Okay, you can consider this as my public key. Everybody knows my public key. So public keys are public. Everybody knows the public key of each other. But the password, my password plays the role of private key. Only me know what's my password. Okay? So in asymmetric cryptography, everybody has 2 keys: public key. All persons in the network knows the public key of each other. The second is the private key, which is really private. Only one person, the owner, knows the private key. Okay, how it works? Now, suppose that, again, Bob wants to send a message to Alice. Now, using asymmetric cryptographic algorithms. Bob has a message. Bob has a message. Now, Bob must encrypt the message with the Alice public key. Okay? Bob uses an encryption algorithm like RSA, encrypt his message with Alice public key. As I said, everybody knows the public key of other persons. So Bob knows the Alice public key. Using Alice public key, Bob encrypts his message and sends the encrypted message to Alice. Okay. Now Eve may have access to this encrypted message, but he cannot decrypt it. Only Alice can decrypt this message, decrypt with his private key. So Bob locked the message with the public key of Alice, and Alice unlock it by her private key. And this is the general idea of asymmetric cryptography. It doesn't matter what's your algorithm, RSA or elliptical curve. All the algorithm have the general form. Okay. For encryption, we use public key of receiver. For example, if I want to send a message to Zainab here, suppose that I want to send a message here, and I want only Zainab can decrypt my message. It's just an example, okay? I must use the public key of Zainab to encrypt my message. So Zainab can decrypt the message with her private key. Okay? And another thing. Now, again, this is Bob. Now, Bob has a message, or not message, I say Bob has a document. Okay? Now, another important thing I forgot. Both public keys and private keys undoes each other. It means that if you encrypt a message by the public key, okay, if you encrypt, you can decrypt it with private key. And vice versa, if you encrypt a message with a private key, okay, you can decrypt it with the public one. Private key and public key is totally different for everyone. Hassan, as you asked, the answer is not only private key, but also public key is different. I have my public key, I have my private key, you have your public key, you have your private key. I have my email address, you have another one email address. Okay? So everyone has a different public key and private key. So public key and private key undoes each other. Okay? So consider this situation. Bob has a document. Now, Bob encrypts the document with his private key. Bob encrypts the document with his private key. And now send the encrypted document to the network. Okay. Now my question is, can I say now everybody can decrypt the message? True or false? Bob encrypt a document with his private key, send it through the network. Is it true or false? Other people in the network, when received the encrypted message, all can decrypt the message. Why false? It's true. It's true. Everyone has the public key of Bob. As I said, public key and private key undoes each other. So, since other persons have the public key of Bob, so simply can decrypt the message, so simply can have access to document. Okay? Understand? If Bob encrypt a document, a message with his private key and send it through the network, others simply can decrypt the message because all of them have the public key of the Bob. Okay, so what's the application of this? Is it really useful? Yes, it's useful because I have a document, okay? I have a contract. Suppose that I have a contract. Not only I publish the contract, but also I publish the encrypted contract with my private key. Both. What's the benefit? The benefit is that if someone wants to fraud me, if someone wants to change the contract, this encrypted data prevents him. How? If you encrypt this message with my public key, you will have a contract. If these two contracts are different, so it means that someone has changed the contract. So this encryption data prevents others to change my contract. This is called digital signature. This is called digital signature. And all these concepts are used in cryptocurrencies. So if someone asks what is digital signature, digital, let me type, digital signature, I will explain them through slides, I will implement them through Python, so don't worry. What's digital signature? Digital signature is the encryption of a message with the private key of the publisher. So publisher, using digital signature, publisher, for example Bob, we have a publisher, as I said, for example Bob, publish not only the message but also the signature inside. What is signature? Signature is the encryption of the message by the publisher private key. Others can simply decrypt the signature with the public key of the publisher. If the result is different from message, it means that someone changed the message. Okay? So, in blockchain, blockchain, each block, at the first of the block, there's a data. What is the first data? The first data is the hash. You remember hash, SHA-1 algorithm, SHA-256. The first item is the hash value of all the previous block. So what's the application? Why is useful? It prevents changing the block. If someone changed some part of the block, all the hash should be changed, and this prevents it. Okay? What's the application of digital signatures? Okay? Digital signatures prevents double spending. How? Can you hear me? Suppose that I have 1 Bitcoin. Suppose that I want to spend 1 Bitcoin. Maybe I buy something. For example, I buy a laptop. Okay? When I spend this money, I put my digital signature beside. And my digital signature will be stored beside the transaction into the blockchain. So later, I can't double spend it again. I can't claim that it wasn't me. Okay? Because the owner of the private key is myself. Nobody has my private key. And digital signature, as I said, is the encryption of the message by my private key. So private key prevents double spending in all the cryptocurrencies. Okay, that's enough for now. Tomorrow we will have another session. I will talk about RSA algorithm, and later I will implement the RSA algorithm. Then after that I will talk about elliptical curve algorithm, and again I will show you how to use different libraries in Python to implement RSA and elliptical curve, and how to encrypt, decrypt, how to create signatures, verify signatures. We will review all the libraries in the Python also. Thank you. Good evening. See you later. Bye.